Hello, good morning everyone. For today, I will be reporting about multivariate analysis techniques. To be honest, I'm really bad at statistics, so I will be explaining this topic from a perspective of someone who doesn't really like equations, so I hope you will still learn something. So first, let us define what is multivariate analysis techniques. It is a collection of methods for analyzing data in which a number of observations are available for each object. For example, when we measure intelligence, there are a lot of factors or aspects that we take into consideration in order to arrive at that conclusion. So, for example, we factor in the vocabulary, the speed of recall, mental arithmetic, or verbal analogies of the individual. So here we have the different characteristics and applications of multivariate analysis techniques. First, it is empirical. They possess the ability to analyze complex data. Second, it is good for decision making. Having different types of data is helpful in choosing. Third, it is good for developing norms. For example, when you screen an applicant or you um, place a student in a specific honors class or whether you accelerate a student or not, there are a lot of factors that you have to consider. For example, in job applicants, what are the previous backgrounds of these job applicants? Were they good in their previous work? What grades that they have? And then for students as well, were they students with good moral conduct? Do they have good grades? These are the types of things that we have to factor in order to arrive at a decision whether or not this student will be placed in a special section or this applicant will be hired for a specific job. And then of course, for medical exams, in order to arrive at a diagnosis of a sickness, there are a lot of things that we have to do. There are a series of tests that doctors have to do in order to diagnose a patient. And the same goes for psychological exams. In order for a clinician to diagnose a client of a specific disorder, there are a lot of tests, interviews, triangulation in order to diagnose that client. And then, of course, in everyday life, we use that as well whenever, for example, we buy a new phone. Does this new phone have a good resale value? And then, for example, if we buy a car, is this uh, good for fuel consumption? Hindi ba siya aksaya ng gas and stuff like that? Is it user-friendly? So these are the types of things that we don't see every day, but we get to use this technique. Next, let us discuss the classification of multivariate techniques. Okay, so I have a diagram here showing how it is classified. First, there are two broad categories. So it answers the question, are some of the involved variables dependent upon others? If your answer is yes, we have dependence methods. If no, we have interdependence methods. Aside from that, two more questions are used for. First, how many variables are dependent? And second, is the data metric or non-metric? So the data is either quantitative or qualitative, or is the data collected in interval, ratio, nominal, or ordinal? In other words, we have two types of multivariate techniques. One type of data containing both the independent variable and the dependent variable, and the other one for data containing different variables without a dependent relationship. Next, let us discuss the variables in multivariate analysis. First, we have explanatory or criterion variables. So if x is the cause of y, then x is described as the explanatory variable or the causal or the independent variable, and y is the criterion variable or the dependent variable. Second, we have the observable variables and latent variables. So the explanatory variables are supposed to be observed directly in some situations. So for example, what are some variables that are easily observable? Height, race, gender. You can see it directly in the naked eye. If that is the case, then it is considered to be an observable variable. But when there are cases wherein the unobservable variables can influence the criterion variables, it is called a latent variable. So for example, extroversion, intelligence, you cannot see it, you cannot observe it, but it can be determined by measurement. After that, we have discrete variable, which is any value that is obtained by counting. So for example, the number of cats, the number of boys in a classroom, and continuous variable, which is measured to the decimal point. So for example, temperature, height, or weight. And then lastly, we have the dummy or the pseudo variable. This variable takes the value of 0 or 1 to indicate the absence or presence that may change an outcome. So k minus 1, k represents the number of levels of the original value. So the purpose is to represent the nominal independent variable. For the next discussion, I have here the important multivariate techniques. So first, we have multiple regression. This technique is used to analyze the relationship between one dependent variable and several independent variables. The purpose of multiple regression is to use the independent variable to predict the value of the dependent variable. Second, we have multiple discriminant analysis. This technique examines the relationship between a set of more than two categories representing an outcome variable and a set of predictor variables. It is used to verify or to confirm that the predictor variables are classified into the appropriate categories of outcome variable. So for example, when you diagnose depression, the depression being the outcome variable, you need to verify the predictors such as family history or the number of sleeping hours or the self-esteem of the individual. Next, we have multivariate analysis of variance, or more commonly known as MANOVA. This technique is used to test the significance of the effect of one or more independent variables on a set of two or more dependent variables. It takes into account multiple continuous dependent variables and groups it together into a weighted linear combination or composite variable. It will compare whether the new combination differs by the different groups or levels of the independent variable. So MANOVA tests whether or not the independent variable explains a significant variance of the dependent variable. And lastly, we have canonical correlation analysis. So this technique is used to measure the relationship among two sets of variables, almost the same as multiple regression, but in canonical correlation analysis, there are multiple intercorrelated outcome variables. So for example, there is data collected on 3 psychological variables and then 4 academic variables. So there are standardized test scores and gender of, for example, 100 college students. The research will be about how the set of psychological variables relates to the academic variables and gender. How many dimensions, which is the canonical variables, are necessary to understand the association between the two sets of variables. Next, we will be talking about the important methods of factor analysis. First, let us discuss the basic terms relating to factor analysis. First, we have factor. It is the underlying dimension that might contribute resulting to a specific outcome. Next, we have factor loadings, or commonly known as factor variable correlation. They try to understand what the factors mean or how it impacts the outcome of a study. Third, we have communality. It is a squared variance to determine how much variables is reproduced by the factors in a model. And the next, we have eigenvalue or the latent root. It is a measure of how much of the variance of the observed variables a factor explains. Next, we have the total sum of squares. which simply means the sum of eigenvalues of all the factors. Next, rotation, which is from the word itself, it is a different angle that might help in analyzing the data from a different standpoint. And lastly, we have factor scores, which help comprehend what the factors mean. And now let us talk about the three methods of factor analysis. To be honest, I had a difficulty in understanding these concepts in the book, and so I asked for my former psychological statistics teacher to teach me. And this is how he explained it the simplest way he could. For centroid method of factor analysis, it is simply a clustering of data. In this method, we look for the data that is close to each other, and from that, we get the common factors for it to be represented as a cluster of data. So as shown in the GIF on the right side of the slide, the black dots are the data. So in centroid method, they cluster these data based on how close they are to each other. So after clustering the data, common factors are drawn out from the group. Next, we have principal components method of factor analysis. So the goal is to reduce a large scale of data, simplifying it without sacrificing the important information from the large data set, so that even if the data is reduced, it is still well represented. So as you can see here in the GIF in the right side of our slide, the blue dots represent the actual data, and as you can see, as it is moving, it is being reduced. So this technique is a dimensionality reduction method to reduce the dimensionality of a large data set by transforming a large set of variables into a smaller one that still contains most of the information in the large data set. And lastly, we have maximum likelihood method of factor analysis. So the goal of maximum likelihood is to find an optimum way to fit a distribution to the data. Why is that? So that it can be easier to work with. So as you can see in the right side of our slide, the measurements should be symmetrical around the mean so that it will represent the entirety of the data that you have. So basically, if you sum up all the three methods of factor analysis, you can make a research on its own. So for example, there is a behavior, factors displayed in a behavior among individuals you want to find which belong to certain groups. So first, you run a test, which is the initial stage, correlation, for example. Then next, you look at the clusters of where each individual's result rests. So that is the clustering and the centroid method. And then third, look for what factors are present in each cluster. So that's the principal analysis. And lastly, fit it all in one distribution. That is the maximum likelihood. So this is basically an entire research on its own. It is like looking for a factor on resilience, for example. What are the factors that contributed to resilience? That can be a research question. You look for resilient individuals by, for example, running a test, then do correlational type of analysis, and then go for common clustering of behaviors, and so on and so forth. As for my light bulb moment, as I've said at the beginning of my report, I am bad at anything that involves numbers and computations, but my report made me have a deeper appreciation to data that is collected in research and how these numbers or factors can make a study meaningful and useful in understanding what is happening around us. So thank you so much everyone for listening. That is the end of my report.